Welcome, everyone, to a very special Masterclass Explainer. If you are a technical teacher trainee, well, you're in exactly the right place today. We're going to unlock one of the absolute most powerful pedagogical tools you can bring into your labs and workshops, the inductive method. Get ready, because mastering this is genuinely going to change how you think about teaching. Okay, let's dive right in. Welcome to the lab, future educators. Now, we all know that classic classroom struggle, right? You're standing at the front of the room, you list out facts, formulas, principles, and your students, they just kind of nod along, desperately trying to memorize everything without actually understanding the why. It is so frustrating for you as a teacher, and frankly, it's just boring for them. But what if there was a better way? A way where they actually discover the core principles themselves? Here's exactly how we're going to break it down in our explainer today. First, we'll get the inductive method defined. Second, we'll map out the 6 steps to discovery. Third, a classroom example using metals. Fourth, we'll weigh the advantages and limitations. And finally, we'll outline your vital role as the teacher. Let's jump right into Section 1, the inductive method defined, the foundation of discovery. Listen closely here, because the concepts we build right now are going to serve as the absolute bedrock for everything you do in your technical classrooms moving forward. So, what exactly is the inductive method? Well, it's a teaching method where you, the educator, start with specific facts, examples, or observations, and you gently lead your students to arrive at a general principle or conclusion. Our core mantra here is, from specific to general. I really want you to drill that golden rule into your minds right now. Specific to general. That is the engine driving this entire philosophy. You know, the true nature of this method completely flips the traditional script. Because it moves from the particular to the general, it inherently becomes student-centered. It's a true discovery method. Instead of you just handing them the answers to memorize, which we know doesn't work long-term, it actively develops their reasoning and thinking by encouraging self-activity. They aren't just absorbing information, they're actively building their own knowledge. And this brings us to the complete roadmap of the inductive method. This represents the entire journey we're dissecting today, starting from the meaning and definition at the top, flowing down through the individual steps, the practical examples, and all the way down to your specific role as a teacher. Consider this your ultimate cheat sheet for the classroom. Moving right along, let's step into Section 2, 6 Steps to Discovery, the Mechanics of Learning. So we have the theory, but how does it actually work in practice? We're going to break down the exact steps you'll use to execute this perfectly in your technical labs. Picture yourself in your workshop right now executing this progression. Step 1, presentation of examples. You provide specific instances or objects. Step 2, observation. Your students carefully inspect what you've just given them. Step 3, comparison. They actively look for similarities and differences. Step 4, generalization. This is the magic aha moment where they formulate a rule. Step 5, application. They take that brand new rule and apply it to totally new situations. And finally, Step 6, confirmation, where the conclusion is solidified by testing it against even more examples. Let's move straight to Section 3, a classroom example, metals, putting theory into practice. Putting theory into practice is absolutely essential for us technical educators. So let's look at a concrete, real-world scenario straight from a science lab. First, you present the specific facts. You literally hand your students pieces of copper, iron, aluminum, and gold. They observe them, they compare them, and they realize, hey, these are all hard and they're all shiny. Then, through your careful guidance, they arrive at the general principle. They confidently conclude that all metals are hard and shiny. This perfectly illustrates that specific to general flow. You didn't tell them metals are hard and shiny. They discovered it for themselves by examining the raw materials. Now, let's transition to Section 4, Advantages and Limitations, Weighing the Method. As professional educators, we have to be realistic. No single pedagogical tool is perfect for every single situation, so let's put on our critical thinking caps and evaluate the pros and cons here. The advantages of this approach are incredibly powerful. Because students are figuring things out for themselves, it intensely develops their power of observation and encourages active participation. Literally no one is sleeping at the back of the class. It develops robust reasoning and logical thinking skills. And because they did the heavy lifting to arrive at the conclusion, it leads to truly long-lasting learning. This isn't just memorize and forget. This is practical knowledge they can use in real-life situations. However, and this is where we really need to be grounded, there are limitations. A good teacher must recognize that this method is highly time-consuming. You simply cannot rush discovery. Furthermore, it's just not suitable for all topics. Some things really do require direct instruction. Most importantly for you trainees, it requires skilled teaching to guide a classroom without accidentally giving away the answer too early. And frankly, it might be pretty difficult for some students who are heavily accustomed to just being spoon-fed information. So, where is the sweet spot? Well, the inductive method is practically custom-built for science subjects and mathematics, which is exactly the domain many of you will be teaching. It is absolutely perfect for establishing generalizations and principles and for solid concept formation. When you need your class to grasp a core physical law or a mathematical theorem from the ground up, this is your go-to strategy. Which brings us to our final part today, Section 5, your role as teacher orchestrating discovery. You might be sitting there thinking, okay, if the students are doing all the discovering, what exactly am I doing? Well, your role actually becomes more important, not less. Consider this your ultimate teacher's playbook. You are essentially the conductor of this orchestra. Your duties are precise. You must carefully select suitable examples. You must present those examples in the proper logical order to build the path. You're there to guide the students to observe and think, gently nudging them when they get stuck. You help them shape their final generalization so it's totally accurate. And finally, you confirm the conclusion. You are the crucial guide making this entire journey of discovery possible. So, as we wrap up this masterclass explainer, I want to leave you with a final, somewhat provocative question. Are you ready to turn your students from passive listeners into active discoverers? The inductive method takes patience, it takes practice, and it takes a lot of skill, but the payoff, seeing that light bulb physically go on in your students' eyes because they figured it out themselves, is unparalleled. Get out there, start experimenting in your technical labs, and let the discovery begin.